Yeah. Okay. So I believe, let me stop sharing real quick just to make sure that I'm recording. I am recording. Awesome. Okay. So we've got Caesar cipher. It takes in a secret and it takes in a number of letters to shift. Okay. So what I'm going to do first is I'm going to translate the problem here. So Caesar cipher should return an encrypted version of the string shifted by the number of letters supplied. Okay, so you're telling me that I need to do, what does encrypted mean? Encrypted means that like it's a copy with different letters. Okay, so you want me to copy the string with different letters that are determined by something, okay? And I'm going to take this determined by something, and I'm going to try to kind of translate it as I read through the prompt. Encrypted version of the string shifted by the number of letters supplied. Okay, so determined by shift something. For example, the string ABC shifted by 2 should return CED. Okay, so it's telling me that for each letter, I'm incrementing down the alphabet the number of shift, determined by shifting letters down the alphabet a certain amount. And they also give me an example. So I'm going to go ahead and write down that example. So ABC should give me CED. A, B, C is 2. B, I think this is supposed to be C, D, E. Okay. Right? B, C, D, C, D, E, right? Okay, spaces between words should not be rotated. Okay, that gives me another case. I could say like A, B, C should give me C, D, E, right? Now I've got two, let's call these examples. Note that any shifts that exceed the number, that exceed the end of the alphabet should wrap around. All right, so letters at the end of the alphabet should reset to the beginning if shifted past Z. For example, XYZ should return ZAB. Okay, so there's another example. ZAB should return, XYZ should return ZAD. XYZ, ZAB, and all of these are 2. You can assume the shift number will always be a positive integer, okay? Additionally, you may assume that the secret string will be lowercase. Okay, so this is always going to be lowercase. Okay, so like to walk back what the prompt is, to restate, I'm going to get a string and I need to return a copy of that string with different letters in it. And those different letters are going to be, each different letter is going to be determined by shifting, by finding a letter down the alphabet a certain amount from whatever my current letter is. So if it's A and I shift 2, it'll be C, like A, B, C. Okay, cool. Letters at the end of the alphabet. So if I'm at Z and I shift 2, I need to come back to the beginning. Yeah. Does that make sense? Does that mental model read to everyone else?
Yeah, that's
It
the way I was
does.
reading it too.
Yep.
Yeah.
Okay. All right. So then when it comes, so I've given my restatement, I've given my examples, and now I'm going to do approach. And so like, I think approach can get difficult when you try to do the whole thing at once. So I'm going to just deal with like really small things. I need to get a copy of the string, right? How can I copy a string? I can create, oh, he is not happy right now. Wow. Create like an empty, create empty string, loop through secret, and add current letter to empty string, right? Does that seem like a good approach? Just to create a copy.
Yeah, to get the strings, yeah.
Cool, great, awesome. So what I'm going to do here is going to be a little bit different. I'm going to do kind of like a combination of coding and approach just to like demonstrate. So I'm gonna code that. I'm going to say let's answer equals empty string. I'm going to say for let I equals 0, I is less than secret dot length I plus plus. And then I'm going to return at the end. We've been trying to deal with like separation anxiety. So we've been trying to just like leave him in a room by himself for like 10 minutes. And it's been tough. He does not like it, but he's getting better. Oh, okay. It really, it breaks my heart every time. So, okay, so where was I? Okay, so I've looped through and I'm gonna say let current letter equals secret at I. Okay, cool. So now I got a copy, right? Okay. Let's go back to the prompt. I'm going to copy the string with different letters. So now I need to determine what my letter is. Okay. Determine by shifting letters down the alphabet a certain amount, by the shift amount. Okay, so I'm going to add shift to something in order to determine my amount. Okay, cool. Add shift to some number to figure out the encrypted letter. That feels really vague, but how about like, let's break it down, okay? So to some number. So like, how do I know, and I'll ask a question myself, like, how do I know where this letter is in the alphabet? Right? Does anybody have any suggestions of like how I could find out where this letter is in the alphabet?
Well,
I made a string for the alphabet.
yeah, I did that too.
You made a string for the alphabet. Okay, cool, awesome, cool. Yeah, I think that's a great idea.
Yeah.
The alphabet, JavaScript doesn't really know anything about the alphabet. Like the alphabet is an English language thing that relates all of the letters in the alphabet to one another in a specific order. So like the quickest, yeah, that makes sense that we could say like, let the alphabet equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, L, M, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so, okay, cool. So I have the alphabet. You said that you made a string. What else? Okay, so how do I know where this letter is in that string?
Would you loop through the alphabet?
Loop through the alphabet. Okay, is there a method that might be able to do this for us?
You could use index of.
Yes, I could use index of. I'm going to say current letter letters index. Where is this letter in the alphabet? Or I'm going to say where letter is at in alphabet, right? And I could say the alphabet dot the alphabet dot index of is current letter. So put in the current letter, have this thing figure out where it is in the alphabet. Okay, cool. So now I have where it's at, and I can determine where it should be by doing like where the, how about just like encrypted index equals current letter plus shift. If I know that I need to shift it a certain amount of letters, I can take where it's at, and then I can add however many shift is, however many it's telling me that I should add it to it. Okay, cool.
Just a quick note. So you know, you missed an R in encrypted index variable.
Oh, insipted is what I wrote. Thank you very much. Appreciate it. So I have encrypted index, right? Okay, so now I have where it's at, where it should be. Now, how can I find my letter? Look up letter using encrypted index. Hey, I have the alphabet right here, right? I could say let new letter equals the alphabet at in, just copy paste. Now I got my new letter. Cool. Add shift to some number to figure out the encrypted letter. I've done that. Okay. And now I could take this new letter, since I have it, and add it to answer. Awesome. New letter. So to recap, I created a string known as the alphabet. I added an empty string here. I looped through secret. I got the current letter. I looked up where my current letter is in relation to the rest of the alphabet, what the index is. And then I took this shift and I found my new index by doing, ooh, this won't work. Where letter is at in the alphabet? Wherever, let's just say like current index. Current index plus whatever my shift number is, right? And I used that as the index that I use to look up a value in the alphabet. Add that value to my answer. Does that track so far for everyone?
Yeah, it does.
Yeah,
Yeah.
that's where I got stuck, because I didn't know what to do with the, like the new letter equals alphabet. That's where I forgot I could do the, I forgot I could do that.
Yeah, that you could just look it up with the brackets.
Yeah.
Yeah. Cool. Okay, so if I run this, I think I should pass a couple more tests. Hey, I do. Okay, cool. So now looking at the tests, they're telling me URYY undefined wraps around to the beginning of the alphabet when necessary. Okay, so this jumps over to our Z, our XYZ, right? If it's X, it'll go to Z. If it's Y, and I add 2, it should go to A. Let me make sure I saw everything in the chat. Oh, okay. That decoded. Ooh, Chris used an object. Ooh, you're advanced here. And thank you for the advice with the Kong with peanut butter. I appreciate that. I've never done a live stream, and this is as close as I've ever come. I'm going to pretend like you all are my super subscribers. Is that what they call it? Super subscribers? Anyway, that's a dumb joke. I'm gonna move on. So what I'm gonna do now is
You're natural at it.
Oh, great. Dumb jokes.
No, just live streaming and.
Oh, no.
At
You're
least
pretty good.
you have. I would follow you. Yeah. At
Yeah, I'll
least,
subscribe.
Oh, great. Thanks, guys. I
Yeah,
appreciate
word,
it.
man.
Okay, so where are we at? We are at we're gonna wrap around, right? So like, this is my point though, is that now because we have the rest of this set up, we have a base that we can work with. We have code that we can stand on and say, okay, now I just have to worry about wrapping around. I have to worry about the fact that I have this index and then I have this index and this, there's 26 letters in the alphabet, right? This might be 27, it might be 28, right? So how do I deal with that? So if there's 26 letters in the alphabet, and how can I, if let's say that my number is 28, and I say, okay, I'm starting at 1. The last one, I guess, is 27. Is that how that works?
I think 26.
It shouldn't be.
26.
Yeah, it shouldn't be starting at zero. At 0.
Should we start at 0? Okay, cool. So we have 0, and then we would stop at 25, right? Let's say I'm on 27, and I say, or I'm on 25, and I'm shifting 2 to 27, and I'm saying, okay, this should be 2. How can I get 27 to be 2?
You could just do if the index number turns out to be more than 25. Is it 25 or 26? 25?
Sure. Yeah.
Then you take that total and you minus 26.
How about this?
minus
If the
26.
index is greater than this dot length minus 1, or I guess I could say is equal to, because remember, index is going to start at 0, and this will start at 1, the length. So if it's greater than or equal to 26, right? Then I think you said subtract, right?
Yeah.
Subtract subtract alphabet.
26.
The total number. Yeah.
Alphabet dot length. Okay, cool, sweet. That's awesome. I think that's a really great suggestion. 2 things. 1, what if shift is that kind of breaks it, right? If I'm relying on specifically alphabet dot length, or like 26. There is a special operator for dealing with this. When you divide something, right? When you divide like 10 by 2, right? That's an operator. You'll get 0, right? What if I divide 10 by 3? What am I going to get? Any guesses?
3.3.
I heard a remainder. I have a remainder, right? You're right. I could get a decimal, but if I don't have a decimal, if we all go back to 2nd grade math, what I'm going to get is 3 with a remainder of 1. So there's a thing called a modulo operator, which is this % sign. And what this does is it gives you whatever the remainder is. It gives you, so if I do 10 mod 3, that's going to give me 1, right? 3 times 3 is 9, which is 1. It gives you the difference between whatever cleanly divides into whatever the clean division is and its next clean division. So in this case, it would be like chunks of 3, right? So we have 3, 6, 9, 10, right? It's kind of like the thing that it's really good at doing is like calculating time. So if you look at like a clock face, right, it's a constant circle. And if I said like, hey, what time will it be in 36 hours? There's more than 36 hours than there are hours on a clock, right? There's 12 hours on a clock, but I would go around 12, 1, 2, 3, and I could determine what time it was, right? The other way to say that is like, you could divide by 12 and whatever your remainder is, that's what you're going to get. If I asked you like what time it will be in 43 hours, you'd be like, okay, well, I don't really care about the first 24, right? Because that doesn't matter. You're just asking me what the number is. I don't care that it goes around the clock face a couple times, right? What I can do is divide the number by 12 and then tell you what's the remainder. That's what mod does here. So the modulo operator can be used to figure out like adding and subtracting something within a given range. So if we define our range as 25, I think we said, or also alphabet, oh, it's the alphabet. So our range is going to be the alphabet dot length, right? We could say, hey, do this adding, but also, so if we're within the alphabet, right? Like if I'm at A and I say add 2, B, which is 1, C, which is 2, what's 2 divided by 25? What's the remainder, right? It's 2, right? Because 2 goes into 26 0 times, or I should rather say 26 goes into 2 0 times, and there's a remainder of 2. But if we keep adding and adding and adding, and we get to something like 28, then we would say like 26 goes into that once, and here's the remainder. So like there's a lot of if statements that you could do, and I think that's great. But also part of the reason that you take this class is so that I can show you cool little tricks like this that are really helpful. So the mod operator is awesome. The other way that we can use the mod operator typically is to determine if something's equal or odd. I could say like if number is mod equally divides into 2. If when it's divided by 2, it does not offer a remainder, it is even. If it has a remainder of 1, it's odd, right? So this is typically how you can determine like even or odd stuff. Side notes. Okay, cool. So let's try running that and seeing what we get. Hey, we passed the test. Any questions on that portion? I know that that was probably like a little bit new. Good stuff.
So could you also like right at the top of the function say if shift equals if shift is over what is 25, then reassign shift to whatever that number is, modulo 25.
Yeah. You're saying like if shift is well, that's hard to say because the place at which it is determined that it's going to wrap is going to be here, right? It's whatever the current letter is in relation to the alphabet. But you could also, if you're saying like my example about 2000, is that what you're kind of speaking towards? Like when I was like, hey.
Yeah, kind of like how do you get that new real shift where it would fall in the alphabet, you know?
Yeah, you could do it here and do something. But if you're going to do that, you might as well do it. You might as well do this because this will also take care of that.
Right. It's all encompassing.
Yeah. You might, as opposed to having like this two places where you're kind of doing the same thing, you might as well like kind of truncate it to one line of code. Okay, moving on. So the second part of this, retains spaces between encryptor world. Okay, so you're telling me, oh, like this example, right, where we have A, B. If it's a space, don't if it's a space, don't try to encrypt it, right? So if it's a space, keep the space. Okay, so what you're actually telling me to do is that if it's a space, add it. If it's a space, I don't need to encrypt it. That's what I'm hearing, right? Is that what you all are hearing?
Yeah.
And that's why I say like translating this stuff is half the battle, because that's like something I can code pretty easily, right? I could just say like, hey, if current letter is equal to a space, do answer plus equals space, and then continue. Don't do any of this other stuff, right? Or I could even do like an else down here and have the else follow this. Like that's pretty simple or like straightforward, like language of like, hey, code this, right? So like that's why like I think this REACTO thing is really great, because it gets you to do like translating the problem into like actual codable language, and doing like sort of an iterative process of like, do what you can do. Take a section of this problem and translate it to the point where you have code and you feel good about that. And then have other parts of the problem, like deal with other parts of the problem after you've got like a base. You don't have to do everything at once. You can do it kind of in like in steps. So if I run this, I think it's going to pass. Yay! Hey, there we go. Good stuff. I am going to take a picture of this. I'm going to put it on the Slack. While I do, does anybody have any questions about this one? Or questions about REACTO in general?
I only really have like I would like more clarification on how the index of works.
Mm-hmm.
I mean, because as I understand, it's practically the same as having the brackets and sorting through the string as an array.
Mm-hmm.
But really, like, is there like an essential difference on between using like the brackets and using index of?
Yeah. Let me just make sure that I understand what you're asking. You're saying that it sounds like what index of does is set up a for loop, access each element in the for loop, and compare like whatever I pass in to that element.
Yeah, correct. Yeah.
Yeah. And what is the benefit if that's like, if it's the same as writing all that out?
Right.
So the benefit is that you don't have to write all that out.
Okay.
Yep.
Okay.
And like if I had to do this like 18 times a day, writing for loops are going to get really annoying.
Okay.
Yeah.
Yeah. Thank you.
No problem. Yeah. Great question. Okay, cool. Awesome. So what I will